Hi, this is Annabelle, founder of Gentacle, and you're listening to Function 5.0, the number one podcast on next generation SAP Enterprise Asset Management. This first episode is on the SAP Predictive Engineering Insights and the role of digital twin technology in problem solving. Without further ado, let's welcome two thought leaders in the design and applications of physics-based simulation software, Vatsan Govindarajan and Arnulf Hagen.
My name is Vatsan Govindarajan. I've been at SAP since 2002, so close to 16 years now. Had all kinds of roles, including corporate strategy, product development, and I am heading the digital twin from a perspective of the high-fidelity digital twin that we develop with sensor-driven analytics, so to say. And the second piece of digital twin that I'm heading is our team in New Zealand, which is based on the acquisition of Right Hemisphere that happened in 2012.
I'm Arnulf Hagen. I have been the managing director of FEDEM since 2013 and was responsible for developing the business plan that ended with the acquisition by SAP of FEDEM technology in 2016 and continued so until the merger that took place this summer. Since then, I'm chief scientist focusing on theoretical and methodological development of the digital twin in SAP, the high-fidelity digital twin, as Vatsan said, as well as other physics-based methods in the PEI.
Thank you very much. Back in March this year, SAP announced the launch of SAP Predictive Engineering Insights, which is referred to as PEI. But what really is SAP Predictive Engineering Insights, and what's the role of digital twin technology in this solution?
Let me start. The work on Predictive Engineering Insights started 2 years back when SAP acquired FEDEM. And we strongly believed in a strategy that if SAP or if any, with the advent of digital transformation, if one wants to bridge the divide between the physical and the digital world, as in IT and OT, so physical and the digital world, if you need to bridge the gap between these two, we need to understand the physics behind the physical world, because the physical world is very deterministic. And that was our starting point, where we want to model the physical reality in the digital world and thereby the digital twin. And our digital twin strategy from an asset management perspective was not just having a model. We wanted to have a digital twin that could mimic the behavior of the physical world using engineering, analysis, using simulation tools that are already available. And FEDEM was a good starting point there because FEDEM had multi-body dynamics or had a lot of experience in structural analysis to be able to help us get into this space. So that is what happened over the last 2 years with Predictive Engineering Insights, where FEDEM simulation was built into the SAP Predictive Engineering Insights, because FEDEM focused only on structures. Recently, we announced a big partnership also with ANSYS to really exponentially increase the capabilities of Predictive Engineering Insights into all kinds of engineering domains like fluid dynamics, thermodynamics, semiconductors, entire multi-physics, so that you can address a very, very broad variety of use cases in asset management.
It's very interesting that it will help customers bridge the gaps between the physical world and the digital world. But how precisely will this technology help customers run their assets better?
All users of industrial assets will have to, at all times, rely on observation in order to make sure that it runs proper and that nothing goes wrong unexpectedly. All machinists on the old ships, they used to listen to the engine in order to find out if everything was okay inside the engine. This has further developed now into the situation where there is an almost viral spread of sensors, and combining that with connectivity, all these signals are then received by something. But this something needs to make sense out of it, just like the engine operator in this ship. One way of doing that is with statistics or more advanced machine learning methods to find out if something, whatever it is strange. Another way of doing that is to use the knowledge we have of physical behavior and the asset itself to refine these sensor signals into interpretable knowledge that either a human can use or a machine can use in order to trigger some action if something goes wrong, and also be able to understand more precisely what is wrong than one would have by simply monitoring disparate sensor signals. So the whole essence of PEI is to make sense out of observations. And this sense is made by using engineering methods, which in essence then again is based on the physics. That was the starting point of it all. Use the physics and knowledge of the asset to give rich understanding. And this we call digital twin.
So for customers, can they use such models then for predictive maintenance, for example? I guess that's going to be one of the main use cases for this technology.
The use of this information, it can take different routes, but obviously knowing when something is starting to go wrong is essential when we're talking about predictive maintenance. So definitely this is one of the first use cases. But it's also possible to use this information to alert if something is suddenly going wrong, like if a bridge or a structure has suddenly changed behavior. But the predictive maintenance, of course, is essential.
So just to add to that, I think the predictive maintenance is one piece, right, into predictive maintenance. What we want to go is to move from predictive maintenance and raise the game to prescriptive maintenance. And by prescriptive, I mean it is not just about predicting that there is a failure that could happen, but exactly specify what exactly is the failure about and which components are affected by this failure, because of which there is a maintenance required. What exactly can be done about this to increase the lifetime of this asset? And then even go beyond using simulation, saying, how can you avoid this problem in the future in the long term? And that level of intelligence is what we want to provide, and that is exactly what we can provide with physics-based monitoring.
In that case, prescriptive maintenance is even more advanced step compared to predictive maintenance. Do we still have a lot of people already working at this level? One question that a lot of people have is, who are the early adopters of the technology? What types of companies are implementing pilot projects? And what business value or return on investment they have obtained by adopting the technology?
What we see in condition monitoring cases, because sensors have been there for quite some time, the last few years, the primary use cases are about getting sensor data and doing some kind of analysis on the sensor data. What we see, customers are evolving their need from simple condition monitoring to a much more sophisticated model-based monitoring. So we really see the customers seeking much more business value from it, and the kind of business value that can be delivered only by simulation-based monitoring or only by digital twin. So the kind of use cases we target is like in case of wind, where we really see several applications in remote wind farms where customers really believe the need for sophisticated capabilities in observing the physical asset remotely. Oil and gas is another case where we see upstream as well as downstream. Even in case of downstream refinery, some of the problems customers come up with is, how can you predict corrosion of assets, for instance? Physical phenomena like corrosion is something that makes a lot of sense to do it using physical methods like this. So as customers are becoming more and more aware of the capabilities that we offer, even the use cases that we are asked to solve is becoming more and more sophisticated.
At the moment, it's more, from what I can understand, is used more in extreme environments. You spoke about wind farms, even downstream or upstream cases. A bit earlier about bridges, corrosion problems. So I guess these environments are more extreme. How does this solution apply to people whose problems aren't as extreme?
There are also cases where there are simple compressors where we've been asked to monitor simple assets. I think in the beginning, in case of any technology that comes ahead, what we see is usually you try to apply it to use cases where you can deliver, where you can solve a very, very critical problem. And then over a period of time, you would see the application being applied even to simplistic, much less mission critical issues over a period of time. So it is just an evolution of the technology and the use cases that we will see over the next 3 to 5 years. So at the moment, it is more sophisticated use cases, but eventually I would expect that almost much more simpler assets will be monitored using this kind of technology.
How does your technology stack up against competitors in the market? Why is your approach better? This technology is not quite new. It's been used before, and so why should the customer choose SAP specifically?
I think it's not so much about the technology, it's the combination of assets that we are bringing together. So we have not seen, or to our knowledge, sensor data in combination with an engineering model being simulated in real time or using a simulation engine, engineering simulation engine, on a big data cloud environment that is deeply integrated into a world-leading asset management portfolio. So that clearly is a very strong value proposition that SAP brings to the table together with ANSYS. And we do believe that the combination of assets, world-leading simulation software together with world-leading asset management that SAP has, including, SAP's cloud capabilities and big data capabilities that SAP brings to the table, this is really a very strong value that we can provide to the customers.
One of the main values is the integration with the whole enterprise asset management ecosystem, correct?
Exactly. So we use the data models that we use are integrated with SAP's Asset Core, for instance. We also have an integration with predictive maintenance where we can combine what we do with engineering models with machine learning and artificial intelligence-based models, which are very complementary to each other, and you can really combine these two to deliver very valuable insights. And then if you have something like this integrated with the Asset Intelligence Network and integrated with an enterprise suite that SAP provides, where you're integrating the insights that you get into and making it actionable through integration with SAP's business suite. And that is where real value lies, because it does not remain a siloed system anymore. You can really convert insight into action. There's more than integration. Our next generation asset management portfolio consists of 4 key products. The first product is Asset Intelligence Network. The second product is Asset Strategy and Performance Management. The third product is Predictive Maintenance and Service. And the fourth one is Predictive Engineering Insights. So all these 4 products are cloud products that really help our customers through their digital transformation journey.